Today we're going to be talking about arithmetic sequences. Some new vocabulary for this lesson is sequence. Sequence is just a fancy word for pattern. So a numbered sequence is just a pattern in your numbers. The term of the sequence is talking about what place in line that term has. So if it's the first one in the sequence or the fifth number in the sequence, it's just talking about its place. Arithmetic sequences are when you add or subtract to find your common pattern. So maybe your first term is 5, and then your rule is to add 2. Your first term would be 5. Your second term would be 5 plus 2 is 7. Your third term would be 9, and so on. And then the common difference is just that rule, the rule of adding 2. If you're given the sequence and you need to find the rule, what you do is you take your second term and subtract your first term because you're looking for the difference. So second term minus first term will help you find that common difference. So we started off looking at patterns that said start at 25, and your lesson today actually said first term is 25. So my first term is 25, and then we want to create a pattern for the rule add 9. Well, 25 plus 9 is 34. 34 plus 9 is 43. 43 plus 9 is 52. 52 plus 9 is 61. And 61 plus 9 is 70. So we just created an arithmetic sequence. We started with our first term of 25, and then we had a common difference of 9 where we added 9 each time. That created an arithmetic sequence using this pattern. This is the first term of the sequence, second term, third term, fourth term, fifth term, sixth term. So, you have done sequences before. You just may have not looked this way. So, the first thing to know is that an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. This is very similar to the slope of a linear equation because you have a constant rate, just like that constant rate of change. So you are using the same pattern going up or down each time. In this example, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. So my common difference is 2, a positive 2. Here we're subtracting all the way through, so my common difference is a negative 4. So let's take a look at a couple of sequences and just determine if the sequence is arithmetic. If it is, we're going to find that common difference. So how do I get from 22 to 29? Well, if you have a hard time with that, go to the side and take your second term minus your first term. 29 minus 22 is 7, and we need to make sure that that pattern continues all the way through. So 22 plus 7 is 29. 29 plus 7 is 36, and 36 plus 7 is 43. So that is my common difference. So I would say yes, this is an arithmetic function, and my common difference is 7. The next example had 24, 4, 1, 18. Well, to get from 24 to 4, I'm subtracting 20. To get from 4 to 1, I'm subtracting 3. That is not a common difference. It is not following the same pattern. So we would just say, no, this is not an arithmetic sequence. Sequences are fine if you want to just build them using recursive form like we did at the beginning where you started with 1 and just continued a pattern. But if I wanted to know the 20th term, no one wants to add a number over and over and over and over and over and over again 20 times. So start with something, add it. Find that answer, add it. Find that answer, add it. So we created a formula. The nth term of an arithmetic sequence is the first term, a sub 1, and the common difference, d, is given by a sub n equals a sub 1 plus n minus 1 times d. We decided that that looked like a tricky equation, but really it was pretty simple. We moved the d up front because we liked it better up here because that's how we normally see it when you distribute. And we said that a sub n stands for any given term in the sequence. A sub 1 is the first term, and d is the common difference. So if I had a sub 20, that just meant my 20th term. So don't let these little numbers at the bottom freak you out. They are just telling you what place in line they are talking about. So a sub n is like a variable. It means that you can use this for any term. If you wanted to know the 7th, or if you wanted to know the 20th, or you wanted to know the 14th, you could use the same equation every single time. Okay? So let's take a look at some of these examples. It says, given the first term and the common difference, find the first 4 terms and the formula. So finding the first 4 terms is just like what we did on that first slide, where we started with our first term. A sub 1 means my first term is 8. My common difference is 10. Since it's a positive 10, it means we're adding 10. So 8 plus 10 is 18. 18 plus 10 is 28. 28 plus 10 is 38. And then my pattern would continue. But if I wanted to know the patterns for numbers much further down the line, like the 20th term, I would want to create the explicit formula here so that way I could just plug those numbers in and go. So if it's written in black, it stays. If it's written in red, we sub in the corresponding information for that problem. So for instance, we have a sub n is equal to a1 means my first term. So for this equation, a1 was 8, plus d is my common difference, so plus 10, parentheses, n minus 1. Now, if I wanted to know one of those equations, I could just plug this into my calculator. Y equals 8 plus 10, parentheses, x minus 1, because in our calculator we use x's and y's. And then you can trace your graph to find any term that you want. You could also plug, if I wanted to know the 20th term, I could just plug a 20 in for n. And in my calculator do 8 plus 10 times 20 minus 1. And it would also give me the correct answer. So let's look at one more example like that. Here, a1, my first term, is 29. My difference, my common difference, is a negative 9. All that means is my rule is to subtract 9 instead of add. So my first term is 29. 29 minus 9 is 20. 20 minus 9 is 11. 11 minus 9 is 2, and so on, but it just wanted my first 4 terms. Now, to create my arithmetic sequence, I would say an equals, here for the a sub 1, I have to plug in what my first term was. Well, that was 29. My common difference, since it's a negative, I'm going to be subtracting 9 this time. Parentheses, n minus 1. Okay. Let's look at another type of problem that you may encounter. Still the same information. It gave you your first term. It gave you your common difference. It wants to know what the explicit formula is. It wants to know the first 5 terms. This time they have built it into a table. And then they also want to know what the 39th term is. Okay? Well, let's start with my formula. an is going to stay an every single time. A sub 1 just means my first term, so that's minus 30, or negative 30. My difference is to subtract 3 each time. That just came from the problem right here. And then parentheses, n minus 1. Boom. There's my explicit formula. Now, to build this table, I have one of 2 options. I can put this in my calculator and say y equals minus 30 minus 3, parentheses, x minus 1. Do menu 5-1 and trace that graph. And to find my first term, I just hit 1 and enter. And when I do that, I get a negative 30. Your first term right here should always be the same number right here. Now, if I hit 2, enter, negative 33, all they did was take this negative 30 and subtract 3. My third term, 3, enter, is negative 36, negative 39, minus 3 is negative 42. Now, nobody wants to do this 39 times. 6, 7, 8, 9, 10, 11, 12, and keep going. So we use this formula. You have one of two options. You can plug in a 39 for n and say negative 30 minus 3 times 39 minus 1. Plug that into your calculator and you get negative 144. Or you can graph this and say y equals negative 30 minus 3 parentheses x minus 1 into your calculator. So I'm going to graph that. I'm going to menu 5-1. Make sure when you graph this, you graph it using delete 6. And once you do menu 5-1, if I want the 39th term, I'm just going to say 39, enter. And it brings you up 39, comma, negative 144. And so that is my output when 39 is my input. Okay? Lastly, I want to look at a problem like this. It's giving you the sequence. So you have to find the first term. Well, a sub 1 just means first term. Boom, right here, 22. D is my common difference. How do I get from 22 to 32? Plus 10. 32 to 42, plus 10. 42 plus 10 is 52. So that means my common difference is a 10. Since I'm adding it, I'm just going to keep that 10 as a positive 10. I'm going to find my explicit formula first and say AN is equal to my first term is 22. My rule was to add 10, parentheses n minus 1. There's my explicit formula. I can plug this into my calculator saying y equals 22 plus 10, parentheses x minus 1. Menu 5-1 to trace it. And when I trace it, I'm going to hit 28, enter, because a sub 28 means what is the 28th term. And we find that the 28th term is 292. Another way you could solve this is by just plugging a 28 here in for n and solving that numerically. Alright, and that's arithmetic sequence. Keep in mind that arithmetic sequence is only when your common difference or your rule is to add or subtract.